This is lesson 6.1. It's going to be talking about angles and their measure. The first thing that we have to do is define an angle. Okay, so an angle is where you take two rays, has a starting point and an arrow, and you connect another ray at that same starting point. That starting point is called a vertex. Hopefully you remember this from geometry. And then that other ray is swung so many degrees, or so many radians. You have an opening so far, and that's what forms an angle. So two rays that are being joined at a vertex. Now, standard position has a couple of things. The first thing you have to do is you put the vertex on the origin. Okay, so that center point where they connect has to go right in the middle of the graph. And the second thing is you put the initial ray is your starting ray, on the positive x-axis. Okay, so we're going to draw a couple of angles here in just a second. We're going to draw positive angles and negative angles. The first thing I'm going to do is take my pen and put the vertex on the origin and put my initial ray right there. Okay, in fact, both of the angles have to start like that. So now let's talk about positive angles. I am going to draw an angle that is 230 degrees. So I have to take this ray and I'm going to swing it. Should I stop here? Well, no, because that's 90 degrees, so you have to keep swinging past 90. How many degrees is this? Well, this would be 180 degrees. I wanted 230. This point down here would be 270 degrees. That means I have to stop somewhere here in quadrant 3. Put a little arrow. You swing all the way to there, and that is where you stop. I'm going to label this angle 230 degrees. That would be a positive angle. So a positive angle swings counterclockwise. Counterclockwise. Okay? Or some people say that you start by going up from the x-axis. Okay? If you swung all the way around back to the beginning, that would be 360 degrees. All right, let's go over here and talk about a negative angle now. I am going to draw an angle that is negative 178. So I have to start by swinging down. Let's draw a negative 178 degree angle. If I swing this much, that would only be negative 90. If I swing all the way due west, that would be negative 180. So I'm going to swing almost to that far, and I'm going to stop at negative 178 degrees. Okay, let's just review with everyone. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Okay, that's how they go. So negative angles swing clockwise. Okay, or some people say you start by going down, okay, up or down. All right, let's practice drawing some angles. The first thing that I want to make sure everybody does is draw their initial ray. The starting ray has to start vertex on the origin on the positive x-axis. I'm going to swing 45 degrees. So it might be helpful to know that 90 degrees is up here. Positive angles swing up. You're going to go about halfway. Put a little arrow saying swing this much, and there you go. 90 degrees, or 45 degrees. A negative 90 starts on the positive x-axis, but a negative we're going to swing down. We're going to swing down here, and there's our final ray, or our terminal ray. Terminal meaning ending. Initial means starting. Starting ray on the x-axis. 225 degrees. All right, let's start right here. Since it's positive, we're going to swing up. 90, keep going. 180, keep going. Now 270 is down here, so I'm going to stop in the middle of quadrant 3. Okay, make sure you're in the correct quadrant. I'm not going to count how many degrees you are. You have to be in the general vicinity. Definitely the correct quadrant. 405. We're going to start here on the positive x-axis. 90, 180, 270, 360. Wow, I got to go more than 360. So I have to go in, 405. If I take away 360, I still have to go another 45 degrees. 45 degrees puts me right here in the middle of quadrant 1. So the way that you indicate that you had to swing all the way around and some more is with this little curly Q. You start on the positive x-axis. You You show me how far you swing, you put a little arrow. Okay, you have to have those little arrows to show me how far or which way the terminal ray swung. All right, let's go give some of these a try here. Question E, 720. Okay, initial ray goes on the positive x-axis. 720 is really large. I know I'm going to swing all the way around once. If I subtract 360 from that, that leaves me with another 360. Okay, let's do it again. Swing around again, and the terminal ray is in the same spot. So a 0-degree angle is the same as a 360, which is the same as a 720. Your initial ray is on top of your terminal ray. A negative 120, let's start right here. Negative swings up or down? We're going to have to swing down. Negative 90, keep going. We need some more. Negative 120 is going to stop right here in quadrant 3. Negative 315. Okay, let's put our initial ray. Negative swings down. Negative 90. Negative 180. Negative 270. I have to keep going, but not 360. Negative 315 is right in the middle, again, of quadrant 1. 495. Okay, we're definitely going to have to swing up. My initial ray starts on the positive x-axis. I swing around once, that's 360, and I'm not done. If I subtract 360 from 495, I have to go another 135 degrees. Or let's do it. Here's another 90. Another 135 puts me right here in the middle of quadrant 2. Make sure you show me how many times you swing around with those curly cues. Okay, now here's some questions. We just drew a lot of different angles here, but some of these are quadrantal angles. And which ones do you think are quadrantal? The first one that is quadrantal is B. Look at that, B. I'll tell you another one that's quadrantal is E. All right, now my question for you is, what is a quadrantal angle? A quadrantal angle, quadrantal angle, they stop on one of the axes, okay, the axes that form the quadrants. An angle whose terminal ray is on an axis, comma, forming the quadrants. So a quadrantal angle will stop there, or there, or there, or there, forming the 4 quadrants. If you stop on an axis, you're forming those 4 quadrants. Okay, here's another question for you. Which examples show coterminal angles? Co meaning with or together, and terminal meaning ending. So the question is, which ones end together? They end in the same place. Two angles, two or more actually, that end in the same place. Okay, does any angle end in the same place as somebody else? One of our answers is going to be A. A ended right there at 45 degrees in the middle of quadrant 1. Okay, and who else ended in that same place? Well, D did. D was in the same place. So what's the difference between A and D? Well, A went 45 and stopped. This is a larger angle. You swing around, but you end up in the same place. These are different angles, but they end up in the same place. So we call them coterminal. And somebody else that also ended up in that place would be, G. G ended up in the middle of quadrant at exactly 45 degrees, but he went the other way. He took the negative route. So A and D and G are all coterminal. I don't think anybody else is coterminal with anybody else on this page. Okay, but you have to put all the ones that are coterminal together like a set. Okay, I think we get the idea of angles, and we've done these before in geometry, so now we're going to get a little bit fancier. Okay, we're going to talk about angles in 2 types of units. You can live 5 miles from school. You could also live 2 kilometers. It's just different ways of saying distance. Well, there's two ways of doing angles, okay? There's degrees versus radians. Two different units, but they're both angles. Okay, first of all, let's talk about degrees. You could start here at 0 degrees, put an angle right here. You could swing up so far, due north, that would be 90. Due west is 180. Due south is 270. And if for some reason you swung all the way around back to the beginning, 0 is also the same place as 360. Okay, so one revolution, one time around a circle is 360 degrees. Okay, everyone gets that. Now we're going to talk radians. Okay, radians start right here, and we say 0. You could say radians or RAD if you'd like. Usually there's no degree bubble for sure. Then you know you're in radian form. Okay, and I have to tell you, if you go due west, straight out this way, that's pi. Pi. Halfway around a circle is pi. What if I go the rest of the way, all the way around a circle? 1 pi, all the way back to 2 pi. So a full circle is 2 pi. One revolution is 2 pi radians. Okay, now what about this? What about due north? Not halfway around the circle, not pi, but if you stop at 90, that would be half of pi, or we say pi over 2. Half of pi. 1 pi out of 2, 2 pi out of 2. So if that's 1 pi out of 2, 2 pi out of 2, what would this down here be? You got to think fractions. 3 pi out of 2, and this would be 4 pi out of 2. Yeah, I already have 2 pi. Okay, so let's just write a little cheat sheet here. 90 degrees is pi over 2. In fact, another way to think about this, 180 degrees is pi. That's a factor. Definitely going to have to know when we get to the next page. Okay, 180 is the same as a pi radians. Okay, I want you to think about something else here. What if I take like a grid, and I'm going to think of pi as 3 out of 3. So if I take this, 0 radians, I would have to split this up into thirds. So not thinking of it as halves, but this one right here, if I swing 1/3, that would be 1 pi out of 3. If I go all the way to here, that would be 2 pi out of 3. And if I swung all the way due west, that would be 3 out of 3. So to do radians, you really have to be a fraction lover. Okay, we're going to graph some of these here, and I'm going to use that technique with you again, thinking pi as some sort of fraction. So I noticed there, this is 4, pi out of 4. So I'm going to think of pi, a full pi, as 4 out of 4. That's pi. Okay, so to think of this, what I'm going to do is separate this into 1. Oh, I should have do dotted. 1, 2, 3, 4. And I need to graph pi over 4. So my initial ray is going to start here. I'm going to swing 1 pi out of 4 here, and there's the angle, pi over 4. 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4 makes a pi. All right, let's do this again. Let's think of pi, this time, as 2 out of 2. 2 out of 2. And we have to do 3 out of 2. So my initial ray goes here. 1 out of 2, 2 out of 2, 3 out of 2. Oh, that's right. 3 out of 2 is 270. We're supposed to know that one from up there. Okay, let's think of pi as thirds. So pi would be 3 out of 3. So I'm going to separate this here into thirds. Your initial ray starts on the positive x-axis, and I need to graph 2 pi out of 3. So here's 1 out of 3. Here's 2 out of 3. I'm not going to go to 3 out of 3. I'm going to stop right here in quadrant 2. All right, let's think of thirds. Let's think of pi as 3 out of 3. Okay. All right, here we go. 7 out of 3. So if I think of separating this horizontal into thirds, let's see, if I swing this far, that's 3 out of 3. What if I swing all the way back to the start? 3 out of 3 plus 3 out of 3, that's 6 out of 3 so far, but I needed 7 out of 3, so I need to go 1/3 more. So we're going to go up here and stop. All right, let's do it some more. Let's think of pi this time as 4 out of 4. So I'm going to separate this into fourths. I'll do the bottom 2 into fourths. Okay, so here we go. So we've got 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4. 4 out of 4 is pi. If I swing all the way back home, that would be 8 out of 4. But that's too much. I only need 7. So we're going to swing right here into the middle of quadrant 4 and stop. That is where 7 pi out of 4 is. Okay. Ooh, a negative angle. Okay, so we're still going to think of pi as 3 out of 3, except negative means you swing downwards. So let's separate this one down here into 3. Okay, let me just show you a clearer picture of this. What we're doing is we're separating down here into 1, 2, 3 sections. 1 out of 3, 2 out of 3, 3 out of 3. So we're going to start on the our initial ray on the x-axis. We're going to swing down 1 pi out of 3. That would put us in quadrant 4. How about a negative pi? That one should be pretty straightforward. Negative pi swings up or down? Definitely swings down all the way to pi. There it is, straight line. Okay, another time here we got 3 out of 3. Think of pi in terms of thirds, and we're going to be swinging down, so I can separate this here for you. So we're going to start the positive x-axis. We're going to swing down 2 pi out of 3. 1 out of 3, 2 out of 3. There we go. I don't want to swing to 3 out of 3. That would be negative pi. Which examples here show you a quadrantal angle? They stop on an axis and form one of those quadrants. Which ones? Yes, B is one of them, and so is G, stopping on an axis to form a quadrant. Okay, we're going to practice this tomorrow, so if you're having some trouble, watch it again, and we'll practice it in class. How do you convert between the two? Okay, I told you a very, very important fact on the last page. You guys have to know that there's 180 degrees, and that is the same as pi radians. Okay, so that fact is going to help us convert. If you have degrees and you want to convert into radians, you want these degrees to go away. Okay, so we're going to multiply by something. You want degrees to go away. Degrees have to go in the denominator to cancel out. So I'm going to put 180 degrees down here, and that is equal to pi radians. If you have an angle in degrees, you multiply by that fraction. Now, what if you have radians? Okay, we're going to multiply by a fraction. You want to make degrees. You want radians to go away, so radians are going to go in the bottom. And then 180 would go in the numerator. So as long as you know this fact, that 180 is the same as pi, you're just going to be multiplying by a fraction with whoever you need to cancel in the bottom. Okay, so we're going to practice converting these angles to radians. So I'm going to take 60 degrees, and I'm going to multiply it by a fraction. I want degrees to go away, so degrees have to go in the bottom. And that fact that we need to know is 180 is the same as pi. I can cancel a 0 and a 0. That degree bubble. 6 and 18 makes 3, so the answer is pi over 3. Now let's do 150. We're going to multiply by a fraction. You want degrees to go away, so where do they have to go? In the denominator. 180 degrees is the same as pi. Degrees go away. Zeros go away. 15 over 18. That can simplify to 5 pi over 6. Part C. Let's multiply by pi over 180. Degree bubble cancels. You can cancel slowly or right away. If you know 45, you can cancel by 9. make 5 and 20, or maybe you can cancel right away. It's negative pi over 4. 107 degrees. Okay, degrees have to go away, so they're going to go on the bottom. 180 degrees is pi. Degree bubble cancels. I don't know this one. I don't think 107 cancels with 180. So 107 pi divided by 80, and that's radian form. Ugh. All right, now we have to think about what quadrant it's in. So I want you to think, first of all, pi over 3. If this was 3 out of 3, where would 1 out of 3 be? 1, 2, 3. It would be right here in quadrant 1. Okay, where would 5 pi out of 6 be? I want you to think of pi as 6 out of 6. 6 out of 6 is over here. So where's 5 out of 6? Yes, right here in quadrant 2. Okay, we're trying to practice thinking in terms of radians because that's the one that's usually more challenging. Okay, let's think about C. Negative pi over 4. We're going to have to swing down. Here's 4 out of 4. Here's 2 out of 4. 1 out of 4 would be right there in quadrant 4. And, oh, this is weird. Okay, so we're going to think of pi as 180 over 180. If this is 180, what's halfway there? 90 out of 180? So 107 would be somewhere here in quadrant 2. Oh, that's good practice. Okay, state what quadrant each angle's in and then convert it. Okay, let's see if we can maybe think about the quadrants first. 1 out of 6. Do you know what quadrant that would be in? 1 out of 6? That's going to be right there in quadrant 1. Part B, 3 pi out of 2. Let's think of pi as 2 out of 2. So here is 1 out of 2, 2 out of 2, 3 out of 2 would be down there. So which quadrant is that in? It's not in quadrant 3. It's not in quadrant 4. Oh, you can't say a quadrant. He's on the line. It's a liner. He's not in a quadrant. He is on the y-axis. That's a tricky question. Do not say one of the quadrants. You can't be in both. Okay, which quadrant is negative 3 pi out of 4 going to be in? I know I have to swing down. And let's think of this as 4 out of 4. So where would 3 be? 1, 2, 3. It would be there in quadrant 3. 7 pi out of 3. Ooh, this one's going to wrap around a little bit, right? So let's think of pi as 3 out of 3. If I go due west, that's 3 out of 3. If you go back home, that's 6 out of 3. And you need a little bit more, so that puts you into quadrant 1. 3. What's a 3? Oh my gosh, 3. I know this is pi. And there's no degree bubble. No degree bubble means that this is radians. Does anybody know what pi is? Yes, pi is 3.14. So where would 3 be? Just right before it. Oh, that is so tricky. 3 is a little less than 3.14, which we call pi. Okay, and now we still have to go and do all the conversions for this. So let's take a look at pi over 6. I want to convert this 2 degrees. I want radians to go away. So radians are going to go in the denominator. And I want 180 degrees. Pi's cancel. Degree bubble is now there. 180 divided by 6 makes an angle of 30 degrees. Does 30 degrees belong in quadrant 1? Absolutely. Part B, let's take 3 pi over 2 and convert it to degrees. If you want radians to cancel, let's put it in the bottom. I'll put degrees on top. The pi's will cancel. 2 goes into 180, makes 90. 90 times 3 is 270 degrees. Is that what we said? Yes, he's a quadrantal. Ooh, let's put that. Quadrantal angle. Part C, we've got negative 3 pi over 4. I want degrees. So radians go on the bottom. 180 goes on top. Cancel, 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 cancel. Cancel by 4. That's going to make 45. 45 times 3, that's going to be negative 5. Carry the 1. 135 degrees. Does that look right? Negative 135? Yes. 7 pi over 3. You want degrees, so you want 180 on top. Pi goes in the bottom. Cancel, cancel. 3 goes in 80 60 times. So we've got how many degrees here? 420. Well, that's more than 360. Does that look right? Oh, yes. 360 plus some more. That looks good. And finally, 3. There's no degree bubble. Don't add it. That means radians. This means radians. So you want radians to cancel. You put the pi down there, and you put 180 on top. Okay? Now this is weird because when you multiply, that's 540 degrees over pi, and that's how you would leave it. Because 540 doesn't cancel with a pi. Okay, can't wait to see you tomorrow.